Hello everyone, it is currently 4:30 in the morning, so this is the perfect time to record a new video. And this one is going to be a bit of a weird one, because this time we're not making a graphics card go faster, this time we make a graphics card more dead. So, bit of a backstory. Today, this card arrived, and as you can see, this very much looks like the same card. Because it is. Both of these cards I picked up as dead. Both of them I did the heat gun method on. Both of them started working again. And yeah, so in some past videos I was talking about how basically I have 3 cards that I can think of off the top of my head. There's a 4th card that doesn't need it but could use it, by which I mean an E-power. So I have 3 cards that don't work. I have a 4th card that could use an E-power but doesn't need it. So yeah, so I very much like to have E-powers, and I'm going to make these myself because buying actual E-powers is very expensive. And yeah, since I have so many GTX 580s, I was talking about in a couple of videos that I may be thinking about sacrificing one of my cards for science to get an E-power out of it, and maybe also some fun experiments, because if I'm gonna kill the card, I'm gonna have some fun with it. So, this card arrived today. It is a Zotac card. It is using the same PCB, it's using the same cooler, the same BIOS. The difference is, this one is not modded, obviously. This one is modded, and there have been some, changes I'm going over. Difference is though, this one is running Hynix AFR. This one is running Samsung E-Die. And this one is having a bit of a memory clock issue. This clock's really, really low, which I think it might need another run under the heat gun so that the memory is just slightly unstable. Or I just kinda got unlucky and got bad E-Die, which should be fixable with caps and a volt mod because it's E-Die. From what I know, it will scale with voltage a lot. Other than this other trash, this memory is literally the worst memory I've ever seen. And this core is literally the worst core I've ever seen. The core on this card is not super great, but it is decent. Actually, I've already fully binned this card on the binning chart. And this actually, like, on low voltage, it's like 20 or 30 megahertz better than this core, which still makes this the second worst core. But then on high voltage, this one actually matches the 90% ASIC quality 580 FE, which is this card. Same PCB, but this has a better than 90% ASIC quality, while this is better than 60%-ish. So yeah, this does seem to happen a lot of voltage scaling, whereas this one is far off. So this was doing 975 megahertz, this was doing 945. So that's a 30 megahertz difference, if I'm not mistaken. So yeah, so basically what I said, I don't know if I mentioned this on video ever, but basically what I said is I decided to pick this card up. Also as broken, I paid 15 bucks for it. Well, actually slightly less because I got refunded some stuff because shipping ended up being cheaper. And I decided, if the new card is not fixable by heat gun, I'm gonna turn this into an E-power. If this is fixable, if I get this fixed and it is worse than this card, I'm gonna turn this one into an E-power. If this is getting fixed and it is better than this card, I'm turning this into an E-power. Well, this was fixed and it is better. So, this card is going to meet its maker. I'm going to kill it. I'm going to purposefully kill a good card. And with good I mean it's working. It's very much not good in terms of clocks. It's literally the worst card I have. Even with, this card has well, like the 480 is also fairly modded, but this one has a lot of mods on it, and it is still the worst card. That's just how bad it is. It is awful. So yeah, I have decided that I would like its VRM much more than I would like the entire card. So yeah, at the end of this video, or maybe this video series, depends on how long it is, I'm going to go over some mods I did, so this is going to be a fairly long video if I do it in one stretch. But yeah, so this card is very bad, and the VRM on it, it's not super special. Zotac even actually cheaped out on the MOSFETs. The MOSFETs that this one is running is, as far as I know, the MOSFETs are even worse than on the reference card, which makes this even more awful for powering a 580 core, but I'm not gonna use this to power a 580 core. I'm gonna use this to power my 460 SE, my two 970s, or maybe the GTX 670, which is the one that works but has a really crappy VRM and could use an e-power. So yeah, and I'm pretty confident that this card is not going to end up like this over here, which is it has its VMEM VRM working, but VCore has an issue. It shuts down, it doesn't really work. That is probably fixable, but I really couldn't find the motivation to fix it. And yeah, that's mostly because this is from a custom PCB that, as far as I know, no one has ever turned into an e-power before. So yeah, I'm pretty much discovering new things with this. And that issue that I have, oops, that was a very serious bump of the camera, sorry. So yeah, like the issue that I discovered, I would say, I might be the first person to have that issue. With this thing, that's probably not gonna happen, because the 580 reference PCB is very, very, very similar to the 480 reference PCB. And I do have full documentation for how to turn a 480 reference PCB into an e-power. So yeah, this is pretty much gonna be as simple as cut the card, solder the things where the guide tells you to, and this should work. And also I'm gonna have to volt mod core because, well, NVVDD is not gonna work anymore if the card is in pieces. So yeah, but this should work out. Yeah, but before I turn this into an e-power, I'm gonna have some fun with the card. It is really late. I'm not gonna do this now. I'm gonna do the first recording of this video, which, by the way, I forgot to mention, this is camera audio, not studio mic audio, because it is very late and I am very tired. And I'm not bothering setting up the studio microphone because, well, the camera audio is actually, it's not as good, but it's decent. So yeah, I will volt mod the core on this because I do not, basically what I'm gonna do is I'm gonna shoot 2 volts into the core and then be like, hey, this is what happens if you shoot too much voltage into anything. It's gonna be pretty anticlimactic. I presume it's just gonna show a black screen if I shoot 2 volts into it and nothing is going to happen. But yeah, that's what happens if you shoot too much voltage into it. And I do not want to use the NVVDD tool for this because the NVVDD tool applies at startup of Windows. So, I don't know if it's stored in the controller or if the tool is applying at startup of Windows. I don't really know. I don't want to take any chances. So basically, if you set a voltage in NVVDD, turn the system off and then on again, it still will have that same voltage set. And the problem is, if I set NVVDD to 2 volts, kill this card, then maybe plug another card into the system, it's also gonna go to 2 volts and kill the card. Because that would be very not great. So I'm gonna hard mod this and to make sure that really only this card dies. So yeah, I'm gonna volt mod core. This is gonna be the same volt mod that the 480 has, which I can also show real quick. So this is the 480 that I modded. You can pretty much see that it is the same thing. The only thing that's different is basically that the holes are missing and some capacitors are slightly different. But yeah, controller, you can't really see it because there's plastic above it, but there's a solder point there, you solder a potentiometer on. And yeah, this is what the volt mod does. I'm gonna put that back up on the shelf, and yeah. And once the core is destroyed by 2 volts, I'm gonna do one more def experiment with this, because I'm not gonna run I'm not gonna run a benchmark on this at 2 volts, because that will surely blow up the VRAM, and I do want to keep the VRAM. So I'm just gonna sit on desktop and set it to 2 volts, because yeah, it's not gonna draw any current on desktop, so the VRAM will be fine. The core will be absolutely destroyed though. And yeah, I might also test some high voltage on the memory, but the thing is, this is Hynix AFR. This literally does not boot over 1.6, was it 1.65 or 1.7 volts? You don't have to go a lot higher in voltage for this to straight up not boot anymore. This is one of the worst memory I've ever seen in terms of how great it responds to being modded. So yeah. And then once the core is dead, I thought that I am going to do the meme and take the cooler off and cook a bit of meat on the naked GPU, because it should still get hot even when all the oxide gates in the GPU are destroyed. So yeah, I'm gonna cook something on the GPU, and maybe even kind of depends if it has over temperature protection. I think it does. If I can somehow get around that, I will absolutely destroy the GPU. Like if you've seen that Gamers Nexus video where they blow up a 2080 Ti, I'm going to do the same thing. I'm going to heat up the GPU so much that it literally shatters. So there's going to be a few fun recordings of this thing dying. And after that's happened, I'm gonna steal, I'm gonna steal the capacitors first, because I don't know if these can take 2 volts. Yeah, like these are 2.5 volts. These are gonna take it, but I don't know about these. So yeah, I'm gonna take all the SMD polymer caps, and I think like the MLCCs should handle it. So yeah. And then I'll just saw the card in half and do the thing. This is probably gonna need a 3.3 volts regulator attached to it. Does it need a 5 volt? I don't know. I don't remember. It either has a 5 volt regulator over here or over here. If it's over here, that's no issue. If it's over here, I'm gonna need to replace it with one of those, with one of these. But yeah, the video is getting kind of long, so let's just go over the mods that I did. I wanted to give this card a second. Well, I gave it a second chance many times. I wanted to give this card one last chance to redeem itself. It didn't. So I did some more modding on this. But first, let's start where things began with this card after I showed it the last time. So you will see that there used to be 6 of these capacitors here, now there are 5, and you're going to see that there's a lot of solder flux around this thing. Now, the card used to be pretty dirty. It is now again, but it was kind of dirty with a lot of flux over it, that I decided I'm going to wash it, I'm going to make it clean. Basically, I wanted the PCB to look clean like this one, which is, yeah, looks pretty nice. So I cleaned it, and while I was cleaning it, I literally just submerge it in water and then take a toothbrush and like scrub it. So yeah, it turns out my soldering was not that great, and this capacitor fell off, and this capacitor was weakened a lot by me scrubbing around. So yeah, while this cap fell off, it damaged one of the multi-layer ceramics that it soldered onto, which I didn't really notice, so I just soldered the cap back on. Because turns out without that cap the card actually artifacts, which is because those two caps, those two multi-layer ceramics were missing. I knocked those off some day before. So yeah, since these are kind of close together, missing these and now missing also that cap probably led to the card, well, artifacting. Put that cap back on, card no longer artifacted, but card now produced smoke. Because that multi-layer ceramic that was damaged, well, it kind of caught fire and it burned out to a crisp. I think I still have it on my desk somewhere. Is it this one? Might be this one. Can't really see anything. I have it somewhere on the desk. I just flicked it away. So yeah, that cap caught fire. And then also because this cap was weakened while I was soldering this one back on, I must have nicked it, like touched it one more time, and then it fell off, and it took the two multi-layer ceramics with it that it was soldered onto. One of them is missing entirely, the other one is missing its terminals. I tried to remove them and replace them, and I just gave up after like 5 minutes of not being able to heat the board enough with my soldering iron. And I also decided that I don't really care because there's so much extra capacitance on the core and it didn't do anything. So yeah, at least here at the VRAM, I actually did something to the core. So yeah, I now I put a new multi-layer ceramic there and soldered this cap back on again. So that's that. And then I did the same multi-layer ceramic mod on the memory that I did on the 480 as well. So you can see each memory chip has gained one of those multi-layer ceramic capacitors. Over here, then those three. And then those two that well, those were missing, so I put caps back on there as well. And if you remember the 480, which is running Samsung memory, I don't know what revision. I assume it is E-die, because E-die is older than G-die, and the 480 is, well, pretty old. It's first gen Fermi. But yeah, I can't say for certain. So, the 480, after I did this mod to it, scaled a lot. The memory got very, very fast, and it really liked having multi-layer ceramics on it. What do you think this memory did? Nothing. It didn't even scale 5 megahertz. Nothing. Nada. And yeah, it was at this point that I decided to kill it even more. Because I want this card gone. I'm pretty sure this card hates me and I hate this card. This card really tries to make my day miserable, so I'm gonna give it something back of that by killing it. And yeah, I also put 4 multi-layer ceramics on the back of the core. There's 2 there and 2 there. I couldn't get them in here because my soldering iron tip was too thick. That also didn't do anything because of course it did. So yeah, I just decided I'm sick of this thing. I'm sick of this card. I put so much work into it and it is still, hands down, the worst card I have. And that's not because I can't mod properly. I've modded other cards. Those cards went, like the 480 got a lot faster. The 460 when I modded that also got a lot faster. This one is an asshole. And I want it gone. I want this card gone. So yeah, that's why I'm killing it. And yeah, so what I'm getting out of this is I get to make a funny video where I blow up a graphics card. I get an E-power out of it. I get to steal all the nice capacitors from it. I'm gonna turn the core into a keychain ornament like I did with the, where is it? That other core that I got from the Phantom. And also you can kind of see I sawed the base plate in half because this is actually the base plate that I used for cooling the card when it was on water. So yeah, I sawed the base plate of this card in half. Yeah, I'm actually using the fan from the green PCB one. And also this is the base plate from the green PCB one because I wanted, like, the Zotac card has one good thing, it comes with nice thermal pads that don't disintegrate. And I like the green PCB card much more than this, so I swapped the base plate and like the fan is screwed into the base plate. So this one now has the shitty thermal pads because I don't care about this card anymore. And the green PCB card, which I like because it looks nice, has the nice thermal pads now. This one also has the nice thermal pads because, well, I haven't done anything to this card yet except heat gunning it and testing it a bit. So yeah. Well, I actually managed to get to 21 minutes of this, and this was just meant to be a short beginning take. Well, yeah. So I very much would like to have this card gone. And yeah. I'm gonna volt mod the core. I'm gonna shoot 2 volts into it. I'm gonna kill the core on camera. I'm gonna explode the core, hopefully, if it doesn't have over temperature protection. And then I'm getting my E-power out of it. That's the plan. Pretty much. So yeah. It's time to go, GTX 580 amp. You've been replaced by yourself, just in better. Like, yeah, it's really kind of depressing. Like, this card is the same thing, same PCB, same cooler. And this one wins without any mods. Like, I kind of feel like I wasted my time with that one, which really I didn't. It was practice. Like, this style of mod, which also found its way to the 480, this was practice for the 480 basically. I can now warn other people to not bother modding 1 gigabit AFR GDDR5. And yeah, so that's pretty much it. That really should be it. The video's long enough. I'm really gonna have to look into making this maybe a video. Maybe this is gonna be like an announcement video for what I'm gonna do to the card. Gonna have to figure that. I really don't want to make like a 40-minute video or even an hour or something. So yeah. I can't really say hope you enjoyed until next time at this point, because this is supposed to be the beginning of a video or a series. So I'm just gonna say stay tuned for the next part. At this point I also haven't seen it yet, so I'm excited for the next part because I'm gonna have some fun for this card. I'm gonna pay it back some pain because this thing is painful to deal with. So yeah, stay tuned for the next part. I'll see you then. So hello everyone. I have now volt modded the card. You can see there's a second potentiometer there. It connects to the CLJ8266 and then a ground of a capacitor over there. And I'm now going to do what I said I'm going to do. I'm going to raise the core voltage on this thing until it dies. Hopefully. I actually don't know if my mod has enough voltage range. I wanted to use a 50 ohm potentiometer, but I only found a 100 ohm potentiometer. So I actually don't know where the maximum voltage for this thing is. I'm pretty sure that 1.8 volts will also kill it. So yeah, you can see we are at 977 millivolts. It's because it's idle. I'm not gonna put any load on the card because I do not want to blow up the VRM, which is the entire point of this. I want to keep the VRM. So I'm not gonna do render test or something. We're gonna have to go up from this. Sometimes when the card is doing a little bit, it goes like 10, 50 millivolts or something. I'm gonna demonstrate to you what the volt mod does. So I'm gonna keep holding that probe to the positive end of a core capacitor, and I'm gonna go to the second potentiometer. I'm gonna turn it, and you see we just got up 2 millivolts, 3 millivolts. It's going up and going up and going up and going up. And at some point, we're gonna get some really high voltages. Of course, when you get close to the voltage where it will start to die, I will take the camera and point it at the screen, because, well, there's nothing going to happen here, apart from maybe things blowing up. So voltage is rising. We are at 1.1 volts now. And I'm gonna point the camera to the screen. A bit. So, this is now the screen, more or less. Yeah, so what I'm expecting to happen here is just that when I go high voltage on the card, if it doesn't blow up, I don't know, I actually don't know how much current will go through the car, like, because it scales, it's not scaling linearly, it's scaling exponentially. So 2 volts is not twice as much current as 1 volt, it's 4 times the current. So yeah, if a high side blow, like if just one high side blows up, the power supply is a very good OCP, it's gonna shut down, I'm gonna replace it, I have some MOSFETs in inventory. But yeah, so what I'm expecting to happen here is when we go into high voltage, it might be fine for a while. And then at some point it might start to artifact, it might shut down, or it's just gonna keep running and we're gonna lose video out because, well, the voltage is starting to destroy all the oxide gates in the GPU. So yeah. So I'm now gonna keep raising the voltage off camera. You've seen how it goes up. I'm just gonna do that. It's just gonna keep rising. We are at 1.15 now, 1.2, 1.25, 1.3. Oh, something just caught fire. One of the caps exploded. Well, now this is... yeah. Gonna lower the voltage a bit. This is still smoking. Gonna lower it. Yeah, so I'm gonna show you what happened. So this capacitor over here, oh, it's really hot. Yeah, you see it's no longer aligned because it blew out. Actually, the multi-layer ceramic under it might have blown up. But yeah, there was smoke coming out of this. I really would like to have 2 cameras. I think I'm just gonna point it at the card now. Like, if the screen goes black, the screen goes black. There's nothing really to see there. But if this will catch fire again, I want this on camera. So here we are again, pointed at the card. Really hope it doesn't explode. Like, I might lose some caps, but, well. So see, I brought the voltage down to under 1.1 volt. Like 1.35 shouldn't kill this. These caps are rated 2.5 volts. Just don't like them exploding into my hand or the rest of the system. Yeah, you see it's starting to smoke again. 1.4 volts. Now this should kill the card if I just leave it for a couple hours. Oh, yeah, we have fire. Surprised it hasn't shut down yet. Okay, 1.6 volts. I'm just gonna keep my hand near the thing. The screen is still on, but the card will die at this point. Let's go to 1.6 proper. 1.7. We are 1.7 volts. Okay, I'm gonna keep it here. I don't want this thing to actually catch fire. Because I will try to flick the off switch as soon as possible, but it is behind the test. It's like down there. Yeah, I will not run a benchmark. This will blow up the VRM. If I run a benchmark now, the VRM will blow up. How hot is it getting? The VRM is getting hot, but not a lot. The card should be getting quite hot now. Like, yeah, it's at 71 degrees. Oh yeah, it's starting to artifact. Oh, it's starting to artifact real, like, nah, not really. Like, a few black squares are starting to appear. Nothing really that interesting. It basically looks like some slight memory instability. Now the fan is gonna spin up now because the card is getting really hot. We are sitting on desktop, 67 degrees, and the fan is at full speed. Because, well, 1.7 volts. I'm surprised it's still alive. And also MS Afterburner thinks that it's at 960 millivolts, that's cute. I could actually just raise the voltage in MS Afterburner. No, it's set to stock in MS Afterburner. This is gonna give us the rest to 1.2 volts actually, to 2 volts. It's still alive though. Quite surprised. Like, this is liquid nitrogen voltage. And I really thought that short there, like, I don't really even know if that is a short. I would have expected when that caught fire that the power supply would have detected that and shut down. Which makes me kinda... I mean, this power supply shut down very fast in the past when I had shorts. So I would think that it does that now also. Okay. What happens if I raise the core voltage to 1.05 volts? This afterburner crashed. Yeah, we reached 1.8 volt, and that is it. The card crashed. We have a black screen. It's trying to boot up, I think. Yeah. It's trying to come back. No. VRM is dead. The VRM shut down. So let's take the voltage down again and restart the card and see if it's still there. We should now be at low voltage again. Like, I don't think it's still gonna show anything. No. Okay, if we now power cycle the card. The motherboard is complaining. Yeah, the VRM is still not powering up. Don't tell me I just broke my VRM. Don't tell me I just broke my VRM. Is memory up? No. Yeah, it's not booting. You can see the card is not getting detected. I don't know where the beep came from, actually. Might have been the GPU fan, actually. Because I don't know how beeper, like where beeper would be on this card. Like, yeah, memory is 0 volts. That shows a little bit, but like, yeah, the card is dead. It's dead now. And now what I expected to happen, so I can power this down. Now what I expected to happen here is, I didn't expect the VRM to shut down actually. We now have 0 volts on both memory and core. And this does not mean the VRM is broken. This pretty much means, well, the card is likely tripping some sort of safety thing, and like it's getting shut down. You have a close-up of that cap. Can't really tell what happened. Yeah, but the card should be quite dead now. Let's go ahead and we shouldn't have a short, like otherwise the card would, the system would just lock up and shut down. So, so let's check our resistances. Core resistance. Oh, you can see the multimeter. 300 milliohms. That's a bit low, but the card just ran a lot, like very hot. And we probably just destroyed all the oxide gates in the core. No, it's reading. Yeah, now it's reading 400 milliohms. Like that's okay for the core. Memory 50 ohms. So these are okay. I don't know about the PEX rail down here. If this is dead, then that's no issue, because I'm not keeping this on the E-power. Like, I'm cutting the card pretty much where the screw is. So this is going. But yeah, now we're just gonna take another card. And make sure I didn't just kill my test bench. Which I shouldn't have, but I mean, this is the first time I do this, and I usually worry a lot, too much. So I want to verify that my test bench has survived it, which it should. There's no reason why it shouldn't have survived. Oh, come on. You can see the postcode. P298. And it's a live picture. Okay. Yeah, so it's just a card. It's booting. Don't really want to take, like, taking the camera to the screen is kind of a hard thing to do, but like, this is booting up. It even has the driver initialized from the start because these two cards have the same BIOS on them. So the system thinks it is the same card, which is why I was using a hard mod on this and not the NVVDD tool, because the NVVDD tool, I don't really know how it works, but if it's just waiting for a card to identify itself and then it's telling the card, yeah, go to that voltage. If I kill this with NVVDD, it's gonna kill the other one too, because it will think it's the same card. That's why I wanted to hard mod. Also, I would have to hard mod this because volt mod, E-power, like when I turn it into an E-power. So let's shut this one down. And now we know that 580s pretty much die immediately at 1.8 volts on ambient. Like, I think 1.8 volts is more than what you run on liquid nitrogen. Like, liquid nitrogen is either 1.6 or 1.7 volts. And we just ran 1.8 into this, so this is dead. This is really fucking dead now. I was swearing. It's not good. This is a family-friendly overclocking channel, I would think. So, yeah. Back on the shelf. And now I'm gonna try to figure out why that VRM is not starting up. Maybe it's just that, like, something short-circuited and it's now in short circuit. Like, that thing might very well be in a short circuit. But we just measured, it isn't. Yeah, so The enable signal of the controller might just be pulled low. That could be it. If that's being pulled low, I'm just gonna attach a 3.3 volt source to it, and then it's gonna start right back up. And then we can do the second thing I wanted to do, which is I'm gonna take the cooler off and cook something on the GPU and possibly shatter it to pieces if there's no over temperature protection. So yeah. Guess yeah, I'm gonna stop recording now and try to figure out why the VRM is not powering up. Probably it's like some safety function, the enable signal is getting pulled low, whatever. I'm gonna shoot 3.3 volts into it. We should be in business. If not, I might be upset because I just killed an e-power. But yeah, let's see. So, I have removed the short from the back. This is the capacitor, I think. Yeah, this is it. It had two very much dead and burned multi-layer ceramics under it. I just removed these. So I have the card on some Lego pieces. Yeah, so there. I removed that. That's empty now. Don't really care about it. The card is dead at this point. And yeah. So removing that actually brought the core VRM back up. So the core now gets voltage again. The memory is slightly malfunctioning. The memory sits at 300 millivolts and the core is getting 1.1 volts. Once I turn that thing into an once I cut the card, I'm gonna look into getting the memory VRM working. The important bit is the core VRM because, well, if the memory VRM doesn't work out, I'd still have this, because here the memory VRM does work. It's just the Z-power is kind of big. So I would like to have both rails working on this. Well, actually, I could e-power the MSI 970. That one has a working memory rail, but on the 460 SE and the Palette 970, I need both rails e-powered. So yeah, I now have the card hooked up to PCI Express power, normal power. The cooler is off, there's still a VRM cooler on it. And it still does the sound. I think that is coil whine or something. The memory rail might be what's making that sound. But yeah, I'm now going to turn the card on with nothing on it. And, well, I'm not gonna use a bit of meat, I'm gonna use a bit of cheese to melt. So yeah, that's gonna look interesting too. And the PSU is already jumped. I just turn this on and I think you can hear the sound. Oh god. You can see what's bubbling. Oh god. Oh, it shut down. This was fast. This was really fast. Wow. Yeah, I think this might have shorted out like the fat, like the, yeah, it is fat. That's what it's called, right? It might have shorted out some of the capacitors. I guess I should have used less of it. Or the core might have tripped over temperature protection if it has it. I don't know actually. Let's try again. Yeah, it's going again. Like if the sound disappears, the card shuts down. You can see again, it's starting to bubble up. And now it shut down again. Yeah, so this is this is the heat that a GTX 580 puts out. It's enough to melt a piece of cheese in literally seconds. Though this is putting out more voltage than stock, like this is at 1.1 something volts. Yeah, but I have a bunch of cheese and thermal paste lumped together. I guess what I'm gonna do with this is the cat gonna like it. I don't think the cat would like the thermal paste that's in this. Yeah, I guess I could try to dispose a bit of it and use less. Just gonna take some that, come on, that stuff and like just a little bit this time. Come on, go away. Oh. So, let's see what it does this time. I think it's over temperature protection, it's shutting it down. Actually don't know if the sun picks up on the camera. You can see the GPU is hot. I can smell the cheese bubbly. Mmm. And it shut down again. Yeah, this thing has over temperature protection. So it smells like cheese. Like grilled cheese. Oh, this is going for a long time this time. Maybe it doesn't have over temperature protection. Maybe it's really just the fat from the cheese shorting it out. And the tone changes from the VRM, what I think it is. This core, now it shut down, okay. This core might actually shatter from how much heat I'm pumping into it. Because if I just keep power cycling, it's just gonna expand and contract again and expand and contract. At some point it will break. It will literally break. I just don't know if I'm gonna manage to do that. Like it might take a long while. I could also just desolder this core and like make it look like this one. This is also a, well, this is, the air is hot around this. So this is the, I mean, it's also a, like you see, it's the same. The substrate is a different color, but like it's also a GF110. This one is from a from the Phantom. That is the other e-power card. I've pulled this core from that one. Went mostly clean. But yeah, I guess I'm just gonna desolder the core as well from that one. And then I have 3 desoldered cores because I also have this one, which is from the 470 that died. This one is not glossy because I tried to lap it. And my sandpaper is not fine enough. Also, if you hear background noises, someone is vacuuming the floor downstairs. I'm sorry about that. Yeah, so I tried to make like die shots with this, and I tried to sand it down to maybe look at the internals, but my sandpaper was way too rough. So that's maybe a future project if I find some finer grit sandpaper. And yeah, let's see the bubble cheese one last time. I'm gonna go really close with the camera. There we have it. Turn on. There it goes. We're making grilled cheese on a GTX 580. Ah, it shut down. This really didn't take a long time. Maybe it's really is shorting something. Yeah, it's shutting down immediately. Or maybe I just destroyed the core even more now. Or like some of the residue is just shorting things. Like the air is very hot. And I'm still like 2-3 centimeters away from the core. Yeah. Bubbles a little. Ah, this time it's going. Nope, shut down again. yeah, so I don't think a lot will be happening now. Have we at least? Yeah, it's solid now. We've grilled it properly. Grilled cheese a la GPU. Wait, what does the underside look like? Come on. Using my screwdrivers for... It's kind of brownish. So yeah, grilled cheese. I really want to eat it now. But I shouldn't because thermal paste residue. Oh, I dropped it on the VRM. Ah! Okay. Let's clean the screwdrivers because fat makes things rust. Also, I think. I don't want my screws to rust away when I use these screwdrivers. Let's try to clean the core a bit. And maybe do a full dry run. Let's see if maybe something's happening. Oh, the VRM is also really hot. Like, this is pumping out a lot of voltage right now. Apparently the fat from the cheese is very good for cleaning things. I'm gonna get rid of the paper. So let's maybe do a few finishing touches with a Q-tip. Doesn't really change much. Oh, I guess there's still a thin film of like oil or whatever. Yeah, so core should be clean. Is it hot? It's slightly warm. Okay, turn it on. And it shut down. Yeah, nothing's really happening. But yeah, it is the air is warm around it. But yeah, sadly no shattering of the core. Maybe... Am I gonna take a hammer to it? Nah. No, I don't think I'll take a hammer to it. If I take a hammer to the core, I'm gonna take the 470 core because that one's already ruined. Actually, yeah, let's do that. So we can look inside the core. Like, this is basically the same thing. It's like it's a GF 100, not a 110, but like you can see it's the same thing. Just that this one isn't... it's matte now because I did scrape it with sandpaper and, well, again, it was way too rough. But I didn't really go deep. So this is basically the same thing, just not glossy. And like a chunk of the core is missing. So yeah. And also I sandpapered the underside. You can still see like where the dot matrix was. So yeah, I'm plugging the PSU so that we no longer can turn it on accidentally. And yeah, so next part I'm gonna have some fun with this core. The core of my GTX 470, which looks bad. Let's clean some of the dust off of it. Yeah, but like... let's take a hammer to this and shatter it and look like what a broken GPU looks like. I mean, you can kind of see it from the one edge that's missing, but yeah, let's do that next. But I'm going to do that outside. So I couldn't find a hammer, so I'm just gonna use this and slam it into it. I'm now outside because I don't want pieces of GPU in my room, which now smells like grilled cheese, by the way, very strongly. But yeah, let's just see what the GPU looks like from the inside. And yeah, actually you can see some of the internal structures. That's kind of nice. That's nicer than I expected. And yeah, you can see that this is a mess. This really shattered a lot easier than I thought. Guess I'm gonna make a picture and send it into the overclocking chat and see what happens. Also, it seems to be frozen. Yep, it is. My feet are now wet. So I thought let's have another close-up to the GPU. So you can kind of see these reddish, greenish, bluish internal structures. I don't think that is the GPU logic itself, because that is kind of deep. I think that is the connection point where the GPU connects to the substrate. But yeah, this actually looks kind of cool. So yeah.